Okay, we said something about having to check these things. So let's get the decimal approximations here first. Clear that out. So that first guy, 3 plus the square root, I don't have 3 there, 3 plus the square root of 85 divided by 2. So I just type that in the calculator, and that comes out to be roughly 6.11. Doing the other one, there you can see that. Here's a quick trick. I really just want to do this exact same expression, but I want a minus sign instead of a plus sign. So quick trick, if you ever just want to edit the previous line, I want that exact previous line, but I just want to change that plus to a minus. Hit second and entry. And that will give you that previous line, so that was second and entry. I'll do it again, second and entry. Well, now I've screwed it up. Oh well, pretend I pretend I didn't do any of that. Okay, let's just type it in there. If I hadn't screwed it up, you could just hit second entry and go back and edit that line, but I screwed it up. So we'll just type the whole thing again. 3 minus, this is how you know that I'm pretty much doing this live. I screw things up. 3 minus the square root of 85, all divided by 2. And that comes out to be roughly negative 3.11. So there comes my 2 answers. Now we said something about checking, that you can't take logarithms of negative values. So if I look at the 6.11, if I put 6.11 in there, that's going to be 1.11. That'll be log of a positive value. And if I put 6.11 in there, that'll be a log of a positive value. So this guy, if I've done all my work, will be okay. However, this answer over here, notice if I put negative 3.11 in here, that's going to be negative 8.11. Log base 3 of negative 8.11 can't do logarithms of negatives, and it's also not going to work over here. If I put that negative number in there, that's going to be log of negative 1.11, and I can't do that. And so this guy, even though hopefully I didn't make a mistake, it's not going to work because I can't do logs of negatives. And so there should be my answer. Now there's not a good way to check this one easily, to make it perfectly check, because of log base 3. If this was log base 10 or a natural log, then I could just type it in my calculator, but there's not a great way to check this perfectly and easily. And so we're just going to hope that I did do it right, because there's not a great way to check it. There just isn't a great way to check it since it's log base 3. We could use the change of base formula and try to check it, but there's just not an easy way. And so on these harder ones, you do have to at least make the small check that you're not getting a value that you absolutely cannot use. And so that negative 3.11, if I were to put it in here, that would result in logs of negatives, and I can't do logs of negatives. So there is that one. Okay, another one of this nature. Again, the key right here, I look at this guy right here, plain number. Just an old-fashioned plain number. And so that tells me to rewrite to 1 log equals number. Which means I'm going to have to do some combining over here. So I already combine these into 1 log. And I'm going to start right here with the power rule. Backwards. It'd be nice if you could see what I'm doing. So let me raise it up and we'll try again. So plain number, look at that. Plain number, that really leads me to rewrite to 1 log equals a number. So I'm going to have to combine these guys. To combine these guys, I'm going to have to start with that coefficient, power rule backwards, exponents can become coefficients. So this becomes log x squared plus log of 4 equals 2. Continue to combine. Product rule backwards. Addition can be put together by multiplying the arguments. So this becomes log, very explicitly, base 10 of 4x squared equals 2. Then I rewrite to exponential form. And that's the base raised to some sort of exponent equals an answer. Bases remain bases. So my base is 10. Logarithms equal exponents. So 10 squared has to equal 4x squared, or that's 4x squared equals 10 squared. 4x squared equals 100. X squared equals 25. Take the square root of both sides. Should include my plus or minus. And I get x equals plus or minus 5. But. That checking thing. Now this one we could check fully out by just plugging that number in there. But we can still see at the top there, log x. I can only take logarithms of positive values, but can only take logs of positive values. So only x equal 5. And so here's one case. Zoom out a little bit, maybe see the whole thing. Yeah, there we see the whole thing. Here's one case where if you forgot the plus or minus on this problem, it wouldn't have mattered because I had to reject the negative solution. But me trying to be the best math teacher I can be, I'm going to put the plus or minus in, then reject it. Because if this was a different problem, if this problem had just started out here, 4x squared equals 100, you would want the plus or minus. But here, because the problem started out as a logarithmic problem, you do need to reject that plus or minus. So these last several examples were log equal a number. 1 log equal to a number. There is another type of logarithm problem. So going on to that other type of logarithm problem, we have this. 1 log equal 1 log. So you still have to do rewriting, but this time the rewriting results in 1 log equal 1 log. When you have 1 log equal 1 log, then we're going to use the following fact here, that if log base b of m equals log base b of n, then m equals n, or that is equate the arguments. That if you have 2 equal logarithms with the same base, then the arguments must be equal. And again here, it's not because I canceled the LOGs or I divided. Again, the real reason is that the logarithm function is 1-to-1. You don't have to remember the reason why. Suffice to remember that if you have 2 logarithms that are equal with the same base, then the arguments have to be equal. So working on this problem here, I note that it's all logarithms, or in other words, there's no plain numbers. And so I want to rewrite two 1 log equals 1 log. So pretty much that's going to mean over here, combine into 1 log. Starting first with that coefficient. So the power rule, and we've already said this a couple times, so I'll just say it, I won't write it down this time. The power rule tells me that that coefficient can go up and become an exponent. And so I have log of x minus 2 squared minus log of 7 equals log of 28. Continue to combine. Now I've got subtraction, quotient rule backwards. I haven't written this one down recently. Quotient rule backwards, subtraction can be put together by dividing the arguments. So this becomes log of x minus 2 squared over 7 equals log of 28. And so now I have 1 log equal 1 log, and so that means the arguments have to be equal. And then you just decide what to do from there. So going on to a new piece of paper here. I'm going to clear my fraction. So I'm going to multiply both sides by 7. On the left, the 7s are going to cancel. So x minus 2 squared equals, and I'll ask the calculator. Should be able to do my in my head, but I didn't try. 196. Now you got a couple options here. The hard way would be to FOIL that out. That'd be the hard way. The easy way, because I have square equal a number, use the square root method. Even when it's kind of a weird, it's not as simple as, over here, I don't think it bothered anybody that I said take the square root. We're used to x squared equals 25. Well, this really is the same form. It's just x minus 2 quantity squared. Include the plus or minus. This works really well because square roots and squares cancel. And so the square root of x minus 2 quantity squared is x minus 2 equals plus or minus 14. That's crooked. And so that's x minus 2 equals 14, or x minus 2 equals negative 14, for x equals 16, or x equals negative 12. But, well, if you have the time, it'd be nice to check out the whole problem. We can still go up to the original problem, which we can't see anymore, so let's bring it down and go up to the original problem. There's the original problem there. I can't take logarithms of negatives. And notice if I put negative 12 in there, then I'm going to have log of negative 14. Can't do that. So I have to reject that answer. And so we come up with 16. Now this one you could fully check out because it's a common log, and we could check the 16 fully by just plugging it in there and seeing if it works. So you could check that one. I'm almost at the end of this video, so I won't. But you always have to make sure that you're not coming up with an extraneous solution. And we did get an extraneous solution here because I can't do that log of the negative. One more video and this section will be done.